welcome to our 2022 NASA Seas Experience. Today, we'll be talking with you about our research fun and the future.
Hi, my name is Ishan Dasgupta. I come from Westwood High School, and I plan on going into computer science.
And I'm Nihar Janga, a rising senior at Vandergrift High School that's interested in environmental studies.
So first, I want to talk a little bit about our research that's titled Quantifying the Need for More EPA Monitors Based on Correlations Between Air Quality and Socioeconomic Factors.
So how did we get here? While we were doing preliminary research to decide what topic to explore, I stumbled across a UN article documenting the horrible situation of Cancer Alley, a region in southeastern Louisiana that is known for its disproportionate exposure to carcinogenic chemicals released by petrochemical industries, and this results in disproportionate health risks for the people in Cancer Alley. So what we wanted to do is look at correlations between socioeconomic data, health data, and air quality data to help find sites like Cancer Alley and report data from them. However, once we ran the correlations, we really weren't able to find sites like Cancer Alley, not even Cancer Alley itself. And so when we looked into the data to see what was wrong, we saw that there weren't even enough EPA monitors in Cancer Alley. So then we shifted our focus, and then we got to the idea that we should look at quantifying the need for more EPA monitors, tackling the issue of not having monitors in the places where they matter. And so while we were thinking about how to quantify this, we were just looking at a literature review just to read up on the topic to get as much background as possible so we could take the next steps. But while I was doing the literature review, I found these articles from like prestigious institutions that showed that there were indeed correlations that did exist that could show sites like Cancer Alley. So from that, I was a little confused because the correlations that we ran were weak while these papers were saying that the correlations were strong. And so once I looked into it further, I realized that's where we could find how we could quantify the need, this gap that exists between existing peer-reviewed research and our correlations that use two different methods of collecting data. And so these are the papers that we use to compare for the literature review with our correlations to get those gaps. And we'll talk about that further in the results.
Okay, but first we need to look at how exactly we conducted this study. So our methodology first includes data collection, and we collected data from mainly three sources, which includes the Census Bureau, SAPI, program of the Census Bureau, and as well as the EPA AQS API using Python. And then we processed said data, and in processing it, we filtered out certain data characteristics of monitors based on, say, certain things like certification and methods. And we also translated units into other units for consistency and clarity when presenting. And then we organized all that data into a single data frame. And then after processing the data, we then could move on to analyzing the data. So we started plotting data on scatter plots, heat maps, bar charts, trend lines. And for all these correlations, we calculated R-squared values so we could compare these R-squared values across graphs. And that leads us to our results. So in our results, we first analyzed the correlation between population and nitrogen dioxide in US counties in order to have a sort of control for our methodology. So we could see just how accurate our methodology was in comparison to the literature review. So if the results of this comparison matches up with the literature review, we would have succeeded. And that's what happened. The R-squared values, which hovered around 0.4 to 0.45, matches up with the results that were presented in the literature review, which shows us that our methodology in calculating this data is correct and can be used correctly to compare with another study.
And so once we established that our methodology was right, given the fact that we also noticed that most of the sensors were in urban areas, and that the literature review that we used compared NO2 to urban population, once we realized that our methodology was correct, we started looking into the places where our correlations really didn't match up. The first thing that we looked at was the correlation between race, specifically percent of the population that was African American versus PM 2.5, which in one of the papers in the literature review showed that there was a significant disproportionate amount of African Americans that were exposed to high levels of PM 2.5. However, the data that we ran from EPA Air Monitor data showed that there's relatively low levels of R-squared, which means that there has to be some sort of a gap between our data that we use and the data that was used in the literature review. This was further reinforced by when we looked at correlations between a certain type of socioeconomic status, poverty rate, versus PM 2.5, comparing that to a paper that indicated that low socioeconomic status tended to have higher levels of air pollutants. And so we didn't just look at PM 2.5 in this case, because the paper did mention that they also use different air criteria. So we looked at PM 2.5, we looked at ozone, we looked at carbon monoxide, we looked at sulfur dioxide, and we looked at nitrogen dioxide. But if you saw while I was scrolling, one thing that you could mention was that we had really low R-square values. Like most of them were below 0.2, which means there's an extremely weak correlation, which completely contradicts what the literature review paper said in saying that low SES or socioeconomic status communities tend to have higher, but this is not what this is showing at all. So again, there's that idea of there's a gap in the data because it's just not matching up with these peer-reviewed, scientifically renowned institutions' research.
Right. And so we started looking at some of the limitations of our study. So one big limitation is that there's a big lack of high quality ground level data in rural areas. So if we take a look at this map, there's a concentration of EPA air quality monitor sites in eastern US, but not so in central US. And that shows that there's a concentration of these sites in urban areas and not so in rural areas. So our study kind of takes an urban perspective, which gives us a biased look. The data is biased, and therefore our results may be limited to that bias. So we are arguing that we need more ground level data on rural areas, because other studies which may be using satellite level data are getting a bigger picture view, but we need that precise ground level data in more areas. And there's also a lack of high resolution socioeconomic data. And what this means is that around one specific monitor, we don't have all the socioeconomic information around the people around that monitor. So we're losing the trends that could be specifically related to the number on that specific area. We don't have that granular level of socioeconomic data, which would be incredibly useful for new insights.
So, conclusion of our study, based on the results, we found that there was a significant difference between our correlations that we ran with EPA monitor data and the correlations that were found through other means such as satellite data in the literature review, which points to a gap in the data. Most likely that is the most plausible reason of difference. But we do want to explore further just to strengthen our case. We want to explore, for example, using more high resolution data, pushing for that more precise, accuracy. And then we also want to look at using purple air sensors, which is another ground level based air quality observation technique other than EPA monitors. Maybe it's a quality thing and not a quantity thing. And then there's also just so many possibilities. We can look at different sectors, health and environment, instead of just socioeconomic. And just looking at all of these things would help us paint a better picture of whether or not we need more EPA monitor data. And so these are the references, the papers that we used in the literature review. But enough of that. Let's get into how the SEAS experience was fun for us.
Right. So this is our air quality initiative team. We had a blast. They're some of the brightest people I know. We went on so many trips. I enjoyed all the time with them. And these are our mentors.
Yeah, I just want to say thank you so much to our mentors for the project that we did. I mean, we definitely would have not been able to do it without their support and their guidance. Sara, Janene, Dr. Pippin, Dr. C, they helped us whenever we needed. We always bothered them with questions. And I'm just really grateful that they were there to help us along every step.
And regarding the future, we just have a few words to say. I love the SEAS experience. It taught me how to combine computer science, my passion, with something like collaboration and working with amazing people like Nihar and the rest of my team. And combining computer science and collaboration really is going to impact me in so many different ways. I'm excited. I'm looking forward to the future because of SEAS. So thank you so much.
Similarly, I've learned so much from SEAS. First of all, just looking at research from a different angle. When me and Ishan first ran the data and found that there was like really weak correlations, I freaked out because what a good researcher wants is good correlations, or at least that's what they say. But from C's, I learned that a good researcher is able to turn correlation or no correlation into something significant. And that's what we did. And I'm really grateful for C's for teaching me that lesson. And just in general, C's has been an amazing experience with friends. They're like my new family. We got a lot of new opportunities, and I'm just really grateful for C's giving me everything. And I really think it's going to shape my life, and I'll never forget it. So thank you so much, C's. We're really grateful.